Now we have understood dimensional analysis, right? We can also find out what the dimensions of different physical quantities. Now we have to understand what are the benefits of dimensional analysis. So the first benefit goes to correctness of physical relation. What is the correctness of physical relation? Just check. To check correctness, we use the principle of homogeneity. So basically, with the help of this correctness of physical relation, that means with the help of dimensional analysis, we can find out whether a given relation is dimensionally correct or not. To use that, we use the principle of homogeneity. What is principle of homogeneity? Let us find out. According to this principle, a physical equation will be dimensionally correct. Dimensionally correct. I missed this one. If the dimension of the terms occurring both sides of the equation remain same. So what does that mean? That means with the help of dimensional analysis, you can find out whether the given equation is dimensionally correct or not. Let us find out one example. See, for example, if I say just like this, half mv square is equals to mgh. Is this equation dimensionally correct or not? So what you have to do, you have to find out this is left hand side dimension, you have to find out left hand side dimension, and you have to find out right hand side dimension. And if these two dimensions are becoming correct, what does that mean? That means this is dimensionally correct. Let us understand what is left hand side dimension. Left hand side dimension, what we have? Half mv square. Half mv square. What is the dimension of half mv square? Half doesn't have any dimension. Mass is m. Velocity has this. So we are getting ml square t to the power minus 1. So this is your left hand side dimension. Now if you are asking what is the dimension of right hand side? What is the dimension of right hand side? What we have? M, G, H. M stands for mass, G is acceleration due to gravity, and H is height. Let us see. So M, G, H. What will be dimension of M? M, capital M. G is what? Acceleration due to gravity. That means L t to the power minus 2. And what is H? H is height. Height means that's length. So we are getting M L square t to the power minus 2. So you can see right hand side dimension and left hand side dimension both are same. So that means this equation is dimensionally correct. That means this equation is dimensionally correct. Okay, fine. Any problem? Now, if I give you another example, everyone, you do this. If I ask you, find out whether this is dimensionally correct or not. Another question. T is equals to 2 pi root over L by G. Is this dimensionally correct? Let us find out. What we have to do? LHS. LHS, what we have? Time. T is what? Time period. Here, remember, T is time period. L is length of pendulum. And G is acceleration due to gravity. So LHS, what is LHS? LHS is time, that is dimension is time. What is RHS? RHS, 2 pi. 2 pi is what? What is 2 pi? 2 pi is a number. Does it have any dimension? No, it doesn't have any dimension. So let me just straight away go to 2 pi L by G. So 2 pi doesn't have any dimension. Under root, length will be L. What is G? G will be acceleration due to gravity. Just see here, L and L cancels out, and if T goes up, we are going to have T square. How can L and L cancel out? This is L to the power 1, here also L to the power 1. So L and L cancels out. So we can say this will be equal to T to the power. If this goes up, this will be plus. That means the root goes up, this is only T. So here also see left hand side and right hand side are also having same dimension. So this is what? Again dimensionally. This is what? Again dimensionally correct. This is also dimensionally correct. Okay. Any doubt in this part? I hope not. If you are not having any doubt, then just do one thing. I am giving you 2 or more numericals. You please try it out. You just tell me. Some practice. It will be V is equals to root over P by rho. This V is velocity, P is pressure and rho is density. Find out whether it is dimensionally correct or not. E is equal to mc square. E here is energy. M is equal to mass and C is speed of light. Do this. If you are having any kind of doubt, do this first. If you are having any kind of doubt, you please contact with me. I'll help you out. Okay. Principle of homogeneity we have understood, right? So with the help of principle of homogeneity, we have found out whether a given relation is correct or not. Now, here is a 2 numericals I have given, right? We are going to understand with the principle of homogeneity how to solve this type of numericals. Let us see. What is given? U is equals to A root x by x plus b. A given equation is there. Here the question is not asked to find out what will be whether the equation is correct or not. They are already stating the equation to be correct. Here it is asked what will be the dimension of A and B. Here A and B are 2 constant. So let us understand how we can do this. So this is already stated that is equal, that means it's a correct equation. Now when they are giving like this, we have to understand left hand side and right hand side both are having same dimension. So we are going to put the dimension and then we are going to go for it. Now before going to, let me ask you a question. If 2 meter plus 5 meter is added, what will be the total length? 7 meter, right? Now if I ask you, if 2 kg plus 5 meter is added, what will be the total length? How is it possible? We cannot add, right? Can we add 2 kg with 5 meter? No, not at all. We cannot add 2 meter with 5 kg. That means similar quantities can only be added. Yes or no? Similar quantities can only be added. Now tell me here, why did I say you this story? X plus b. What is the dimension of x? Dimension of x will be distance, that is L. What is dimension of b? We do not know. But when x and b are added, that means what? B and x should be of same dimension. Then only it can be added. Yes or no? So let us understand from RHS. So this is our solution starts from here. From RHS we can see, x plus b, right? In RHS part we can see x plus b. What is the dimension of x? L. Therefore, what is the dimension of b? We do not know. So when this is added, this should be what? This should be what? Dimension of length only. This quantity should be what? Length only. So when these two are added, I have to get length. When is it possible? Only when b is also length. So length plus length is added. Mass plus mass. Then time plus time, it can be added like this, right? Quantity, same similar quantity can be added or subtracted. So that means, therefore, by principle of homogeneity, dimension of b will be length. Dimension of b is also length. So that means now it became quite easier. That means B is dimension of length. We have found out. Now we have to find out A. Let us put the dimension. Then we see. Now let us put the dimension. Now from equation, how can we put? We can say what is U? U is potential energy. Potential energy dimension will be what? M L square T to the power minus 2. From the equation, that is equals to, what is it? A. Do we know the dimension of A? No, we do not know. Then what we have? Root x. That means under root. X is what? Dimension? L. What is dimension of X? Length. What is dimension of B? We have found out L. That means when they are two added, what will be? 2L or only L? It will be only L. Why? Because a length is being added to a length and we are getting what? We are getting length only, right? That is not 2L. So that means this part is also length. Understand this part. X is length, dimension of L. B is also dimension of length. When these two are added, this will be what? Dimension of length only. You have got it? Clear? Now it became quite easier. Now you can understand. Now we can understand what we are getting. ml square t to the power minus 2, that is equals to A. What will be this one? L to the power. This is what? Half. And when this is going over here, what we are having? Minus 1. Yes, we are having what? Minus 1. So that means this we are getting A L to the power minus 1 means half minus 1 means half. So if I am writing over here, just see, we can have dimension of A will be ml square t to the power minus 2, and this L to the power minus half will come over here. This L to the power minus half will come over here. Are you understanding this part? So what we can write? L to the power minus half. Now if this is L to the power minus half, when it will go on top numerator, this minus half will be added. Law of indices. M L to the power half. This is what you are dividing, right? This is division. When it goes up, right? So you are getting dimension of A will be m L to the power. This is what? 5 by 2. This is t square. 5 by 2. This is t square. So this is what? Dimension of A. So dimension of B and dimension of A we have found out. Is that clear? Please take a note of entire this one, this numerical. Now similarly we are going to do this one. When we are going to solve this one, you are going to help me. So let us do this. Take a screenshot of this part. Okay. Now when we are doing this part, this one, again let us find out. What is E is equal to B minus x square. So x is distance, t is time, E is energy. We have to find out dimension of A into B. Okay, let us do it. Here goes the solution. First of all, you have to find out where is plus or minus going on. Here see the minus is there, right? So this is B minus x square. So B should be having the same dimension of x square, because B is, just see, x square is being subtracted from B, right? So dimension of B and dimension of x square should be same. So we can say by principle of homogeneity, dimension of x square and B should be same. Why? Because they are of same dimension. Otherwise they cannot be added or subtracted. So that means dimension of B should be what? X square. X is what? Distance. That means distance dimension is length, and length square L square. As simple as that. So dimension of B we have found out. Now they are asking what will be the dimension of A multiplied with B. Okay, we have found out B. Let's carry on with it. Now from the equation, what is E? E is energy, right? E is energy. So I am writing dimension of E is ml square t to the power minus 2. What is dimension of b minus x square? This entire part should be what? B is having dimension L square, x square is also having dimension L square. That means what? L square minus L square will get cancelled? No. This is L square, this is L square. Ultimately, this quantity will be what? L square. Quantity, not the value I am subtracting. This is the quantity, right? Give you an example, very short, right? Suppose you are having 5 kg potato in your house. From there, if you take out 2 kg potato, how much kg potato will be there? 3 kg. But it will be potato only, right? It will be potato only. Same thing. This is b minus x square. Dimension of b is what? L square. X square is also what? L square. So after subtraction, what will be there? The quantity will be L square only. Minus at. What is a? I don't know. But t is time. Now from here, L square and L square can be cancelled out. And if t goes over here, and if t goes over here, what we can say? Mt to the power minus 1. Or we can say t to the power minus 2 into t. That is, you are getting 1 by a. So what does that mean? This is minus 2, this is t to the power 1. So from here, what we can say? This is coming mt to the power minus 1. That is coming how much? Mt to the power minus 1. So that is equal to 1 by a. So if you are coming to this part, mt to the power minus 1, that is equal to 1 by a. How it is mt to the power minus 1 coming? Mt to the power minus 2 and t to the power 1, both are multiplying mt to the power minus 1. Then what will be a? A will be what? A will be is equals to m inverse 1 t to the power 1. How? This is mt to the power minus 1 is equal to 1 by a. Mt to the power minus 1 is equals to 1 by a. Then what will be a? A will be m inverse 1 t to the power 1. See, m was 1 here, t to the power inverse 1. So it is getting inverse, right? So this is what? Dimension of a. Now, in the question they have asked, what will be the dimension of a into b? Therefore, dimension of a into b will be what? Dimension of a into b will be m to the power minus 1. M to the power minus 1 t to the power 1. This is a. And what is b? L square multiplied. So this is coming out to be m to the power minus 1 t to the power 1 L square. This is our answer. Got it? So just before the last part that we have seen, we have done the application of dimensional analysis. That is to check whether a given equation is dimensionally correct or not. Now we are going to find out what is the use of dimensional analysis to convert a given quantity from one system of unit to another. Okay. So for that, please focus here. Just see, we all know a given quantity can be written as N1 U1, that is equal to N2 U2, right? We know this. A given quantity can be written as like this. So that means, please be very clear. So that means N1 is the numerical value of the quantity in unit 1 and N2 is the numerical value of that same quantity in unit 2. So what you have to do while you are doing this, while you have to convert, you have to use this method. You have to write it like this. You have to equate N1. What is U1? U1 is a standard unit of a given quantity. So you have to write dimension of that quantity. It can be like M1. This is so N2 see, we don't know that what is the m to the power what, L to the power what, t to the power what. We don't know. This is just a general formula. When I'm going to give one example to you, it will be clear. So this is one standard unit. This is standard unit 2, that is U2. This subscript are signifying which standard unit we are considering. So now we are going to use this method and we are going to solve a different question using this formula. So let's find out. Okay. So here I am giving you an example. Here what is given? Convert 1 joule into urge. So I am going to do this sum and this is for your homework. Okay. So first let us do this. So what is here? 1 joule into urge. This is saying 1 joule into urge. Now okay, that's fine. 1 joule. So joule, what is it? It's a unit of, joule is a unit of energy, right? Joule is a unit of energy. So understand, if I am saying, you have to write like this, 1 joule is equals to how many urge? Okay. 1 joule is equals to how many urge? Okay. So now just see here, 1 joule, that means this is your N1. Joule, this is your U1. You don't know about this, right? This is your N2. You have to find out this. And urge is U2. Now tell me, for a given quantity, the dimension remains same. Whether it is U1 unit or whether it is U2 unit, the dimension will remain same, right? So what you can write over there? So what you can write? N1. What is the dimension of joule or energy? That is M L square T to the power minus 2. But it is in which unit? 1 unit. N2. Dimension remains same. But this is in which unit? 2. Unit 2. That's why I am using the subscript over here. Okay. That's why I am using the subscript over here. Is it clear to all? Now what I am doing, just see here. I know the value of N1. What is N1? 1. What is N2? Do I know this value? No. I have to find it out. So now what I can do here, N2 can be directly written. If this entire part come over here, then what we can write? N1 M1 by M2. What is the power of M1 and M2? 1. What is the power of L1 and L2? 2. What is the power of T1 and T2? Minus 2. Got it? So what I have done? I have taken this part over here. Okay. When I am getting it over here in the denominator this side, M1 and M2 power is 1. L1 and L2 what is the power? 2. And T1 and T2 what is the power? Minus 2. Now very important. N1 is 1. What is M1? M1 is the signifying mass. In which standard unit? In SI unit, joule. What is M2? That is mass. In which standard unit? That is urge. That is the CGS unit, right? Now you tell me, what is the standard value of mass in SI unit? That is 1 kg. By what is M2? In CGS unit, 1 gram. Whole to the power 1. Now L1 by L2. L1 by L2. What is L1? The length. Standard unit in SI unit. Standard value in SI unit. That will be 1 meter. L2. What is it? This is the length. Standard value in CGS unit. That is 1 centimeter. T1. Standard value SI unit 1 second. 1 centimeter. So now, this part we are having no problem. 1 second, 1 second. It can be cancelled out like this. But can I cancel 1 meter and 1 centimeter? No. 1 kg and 1 gram? No. So what I have to do? N1 is 1. That's why I have written 1 here. Okay. So 1 kg we can write here 1000 gram by 1 gram. 1 meter, 1 centimeter. Sorry, this is 100 centimeter by 1 centimeter, and this is 1 only. Now you can see, we can cancel this one. 1 centimeter cancels, 1 gram cancels. So 1000 gram by 1 gram is 1000 and 100 centimeter by 1 centimeter, 100. So now, what is the value of N2 then? N2 is equals to 1000 multiplied 100 square, that is 100 into 100. So how many zeros I am getting? That is equal to 10 to the power 7. Thus, 1 joule is equals to how many ergs? So ultimately we can write 1 joule is equals to 10 to the power 7 ergs. Is it clear? Any doubt? So just like this one, we are going to solve that question. Okay, please do it. You can do it. You can take a screenshot of this one, and by looking into this numerical, you solve that one. I'm going to show you another question. Okay. Okay. So here is another type of question that may come for this conversion of system of units. That is a given physical quantity that you need to convert from one system of units to another. Here is another part. Okay. So here this kind of question may come. This is important. This is a bit difficult from the previous one. Just understand. So what they are saying, find the value of 100 joule on a system which has 20 centimeter to 50 gram and half minute as fundamental unit, okay, of length, mass and time. So let us understand this. Again, the procedure remains same. So a given quantity, so if this is your solution, a given quantity can be written as N1 U1 that is equal to N2 U2. N1 U1 that is equal to N2 U2. Now, you tell me N1 U1 that is equal to N2 U2, right? Now, what is N1? 100 joule. So, you are converting 100 joule into, you don't know about the numerical value of another type of unit. So, you don't know it is CGS unit or any other type of unit. How to do that? The formula remains same. The formula that remains same. So, let us understand. So, this is joule. That means this is again energy. So, 100, this is how what? ml square t to the power minus 2. This is 111. That is equals to N2. This is ml square t to the power minus 2. But this is like this. Okay. This is M2L2 T2. Got it? Now you tell me. The procedure remains same. So, N2 can be written as what? 100 into M1 whole divided by, right? Now, important part is that is from this step, this is M1 by M2, this is L1 by L2, this is T1 by T2. Okay. Now, from here, what is M1? It is in which standard of unit? This is SI unit. But M2, it is in which unit? Given specified unit, I don't know. Now, the important part is over here, that is N2 is equals to 100. M1 I can write what is the standard value of mass, that is a standard value of mass in SI unit, that is 1 kg. Right? This is the smallest standard value of mass, 1 kg. But what will be M2? Just see, that is 250 gram. They have said, specified 250 gram. What is L1 in SI unit? That is 1 meter. 1 meter. What is L2? This is in which unit? I don't know about the unit, but they have specified that is how much? 20 centimeter. And T1, what is the time in SI unit? Smallest value of time? That is 1 second. And what is the smallest value of time in other type of unit? That is already given. That is what? Half minute. That is half minute. Half minute means 30 seconds. That is 30 seconds. Right? Now, can you cancel 1 kg by 250 gram? No. Can you cancel 1 meter by 20 centimeter? No. Can you cancel 1 second by 30 seconds? No. So, you have to make them in one format. One format means 1 kg can be converted into gram. So, we can write N2 is equals to 100. 1 kg I am writing here 1000 gram by 250 gram. This one 1 meter by 20 centimeter. 1 meter means 100 centimeter by 20 centimeter. Then 1 second by 30 seconds. So 1 second by 30 seconds. That is fine. Okay. Now, what we can do here? Just now gram and this one can be cancelled. This will be how much? 4. This will be how much? 5. So N2 will be is equals to 100 into 4. 5 square is how much? 25 into 1 by 30. 1 by 30 whole to the power minus 2. Now if 30 comes on top, what we can write? 100 into 4 into 25. 30 whole to 1 by 30 to the power minus 2. So if 30 comes over top, what we can say? This will be 30 square. Yes or no? I hope you all know the laws of indices. You all know that. So now N2 will be is equals to 100 into 4 into 25. You tell me 100 into 4 into 25 is what? Again 100. 30 square is what? 900. Right? 30 square is 900. So ultimately N2 is equals to 9 into 10 to the power. How many zeros we are having? 6. So ultimately our answer comes out like this. 100 joule is equals to 9 into 10 to the power 6 units. This is our final answer. Is that clear? So with the help of this kind of numericals, I hope you will be able to solve other numericals as well. So please copy it down, students. If you have any problem, you can let me know. Okay. Okay. So another, that is the last one, that what we can do with the dimensional analysis. Another advantage of dimensional analysis is that with the help of this, we can deduce. With the help of this, we can deduce what? The relationship between a given quantities. For example, I have a question for that to explain you. What is given? The velocity v of water waves depends on the wavelength lambda, density of water, that is rho, and acceleration due to gravity, that is g. Deduce the method of dimension, the relationship between the quantities. So let us find out what we have to do. Just see. So what is the velocity? How the velocity depends? Now the velocity depends on wavelength lambda. But how does it depend? Do I know? No. So let us write here A. It also depends on density of water, rho. How does it depend? Do we know? No. And it also depends on the acceleration due to gravity. How does it depend? Do we know? No. So that means that's why I've written lambda to the power A, rho to the power B, g to the power C. Now when we are combining all these three together, we can write, when we are combining all these three together, what we can write? V is directly proportional to lambda to the power A, rho to the power B, and g to the power C. Okay, we can directly do this. Now, to remove this proportionality sign, what we have to do? We have to place one proportional constant. That is, if we have to remove this, and I have to replace with equal to, I have to place a proportional constant, this k. Now remember, this k needs to be, dimensionless constant. This k needs to be dimensionless constant. Here you have to write, it is dimensionless constant. Okay, so here k is the dimensionless constant. Next step is here to put all the dimensions of lambda, rho, g. You have to put dimensions of all these things. Okay, you have to put this. So let us see what we can do. Now v is equals to k lambda to the power a. So putting the dimensions, what we can write? What is velocity? What is the dimension of velocity? L t to the power minus 1. Right? K is dimensionless constant. What is the dimension of lambda? Lambda is wavelength. That is L to the power A. What is rho? Rho is density. What is the formula of density? M L to the power minus 3. Right? And what is G? G is acceleration due to gravity. So this will be G will be acceleration due to gravity. So we have placed all the dimensions of this quantity. Now what you have to do here, L t to the power minus 1, that is equals to, what is the power of L? Power of L is A, and what else? L to the power minus 3, and B is also there, that's why minus 3B. And what else is there? This is L to the power minus 2, that was C, right? G to the power C. So what will be this one? L to the power plus C. So this is the power of L on the right hand side. Similarly, what will be M? You tell me, what will be M? Only B. And what will be T? T will be minus 2C. Now you can see, if I can try to figure out from this equation what we know from the principle of homogeneity, left hand side dimension should be equal to right hand side dimension, right? Now, if it needs to be equal, then the power needs to be equal as well. So what we are going to do, equating the power of length, mass and time. What we can say? What is the power of L here? A minus 3B plus C. That is equal to what? L to the power 1. Right? Now, M to the power B. What is the power of B in the left hand side? 0. And what is the power of T in the right hand side? Minus 2C. Minus 2C will be equals to what? Minus 1. So this is your equation 1. This is equation 2. This is equation 3. Now from these equations, can we find out the value of A, B, C? Yes, of course, we can find out. So see, what will be the value of C? C will be is equal to, this is minus 1 and this is minus 2. So C will be half. When I have got the value of C, we make a square like this. Value of B will be what? We make a square like this. So B and C I have got. And what else I want? I want to find out the value of A. Don't you think from this equation you can find out? So A minus 3B, that is B equal to 0. Right? Plus C. C is equal to what? Half. That is equal to 1. So A is equals to 1 minus half. That is A is also equals to half. So we have got the values of A, B and C. So when we have got the values of A, B and C, so now we can put it over here. We can put the values of A, B and C and we can find out, derive this value, right? So now we can do it here. So V is equal to dimensionless constant K, lambda to the power A. Lambda to the power A is lambda to the power half. Lambda to the power A is lambda to the power half. Next, what we have? Rho to the power B. Do we need to write rho to the power B? No, it's 0. And then what we have? G to the power C. So if you have to write down G to the power C, so you can write G to the power C. C will be what? Half only. So ultimately you can write V is equals to K root over lambda G. V is equals to K root over lambda G. So why root over lambda G? Because lambda to the power half and G to the power half. Got it? Is it clear to all? So this is how we can derive the value of velocity with the help of dimensional analysis. So this is the velocity of water given, right? And with the help of the dimensional analysis, we have derived this formula successfully. Understood? Any problem? Let me know in the comment section.